We're going to continue talking about our special right triangles in trigonometry. Now we're going to look at our other angle measures. We're going to look at our 30, 60, 90 right triangles. So let's talk about what we remember from geometry, 30, 60, 90s. We know that we have a 30-degree angle measure, we have a 60-degree angle measure, and therefore we have a short leg. Remember, the short leg is always opposite the smaller angle. So there's our short leg. We have a long leg, and it's always opposite the larger of the two non-90 degree angles. And then we still have our hypotenuse. And we know the relationships between all of those. All of the relationships in a 30, 60, 90, remember, were based on the measure of the short leg. So here's our short leg, and we're going to call its measure n. So the long leg is always square roots of 3 times the measure of the short leg. So it's important for us to find the measure of the short leg, and then the hypotenuse is twice the length of the short leg. So if we know the length of the short leg, or can find it based on other information we're given, then we can find the measures of all three sides of any 30, 60, 90 special right triangle. So the hypotenuse again is always directly across from the right angle. The shorter leg will always be across from the smaller angle, for us the 30-degree angle, and the longer leg is across from the larger angle, the 60-degree angle. So we just did this a while ago. We have the short leg, the long leg, and the hypotenuse, and we know where they belong on that 30, 60, 90. We also talked about these relationships in order to find the measures of all three sides. We always want to work with the shorter leg because the other two measures are based on the measure of the short leg. We find the measure of the short leg. The long leg is square root of 3 times the short leg. The hypotenuse is twice the length of the short leg. So if we're given a 30, 60, 90 right triangle and we have one measure of a side, here we have the measure of the long leg. So this is the long leg, and remember the long leg is the short leg times the square roots of 3. So right here we've been given the measure of the short leg, and we know that the measure of the hypotenuse is twice the measure of the short leg. So we can, in short order, find all of the measures just based on being given one measure, even if it's not the measure of the short leg. So there's just a little geometry review on 30, 60, 90s. Now we're going to go and we're going to talk about our exact values, because we have a radius of 1, which is our hypotenuse. Our radius is our hypotenuse because we're going to be in the plane, and we're looking for our exact values on our 30, 60, 90 right triangles. We're going to start with our 30-degree angle. We're going to work exclusively right now with our 30-degree angle. And so this is the opposite leg of our 30-degree angle. This is the adjacent leg of the 30-degree angle. So if we were going to talk about the sine of 30 degrees, remember in radians, that's pi over 6. If we're going to talk about the sine of pi over 6, sine is opposite over hypotenuse. So the sine of pi over 6 is 1/2. The cosine of pi over 6 is the adjacent measure over the hypotenuse. So that's square roots of 3 over 2. The tangent of pi over 6 is the measure of the opposite leg over the measure of the adjacent leg. Now we can use some algebra to clean that up. That's 1/2 times, we flip the bottom, right? Multiply straight across, we get 2 over 2 times the square roots of 3. That cleans up to 1 over the square roots of 3. We have to, for some reason, rationalize that denominator. So 1 times the square roots of 3 is the square roots of 3. And we have the square roots of 9 in the denominator, so there's the tangent. And then we could flip those and we would get the cosecant and the secant and the cotangent. So we know how to do all that. That's not a problem for us. So remember, if the short leg is 1/2, the long leg is square roots of 3 times that, and the hypotenuse is twice the length of the short leg. So we're using those 30, 60, 90 relationships to come up with these exact values for our side measures of our triangles. So let's go back, and we've talked about this. We know we have sine, cosine, and tangent. We know that secant, let's talk about the secant of pi over 6. We said that the cosine of pi over 6, let's go back up here, was square roots of 3 over 2. So the secant is going to be 2 over the square roots of 3. Let's rationalize that denominator, and the way that you would see it written is 2 root 3 over 3. Let's talk about the cosecant of pi over 6, and that is the reciprocal to sine. Sine was 1/2, so we know that 2 over 1, or 2, is going to be cosecant, right? If we have opposite over hypotenuse, and cosecant is hypotenuse over opposite, we know that we have 2. And tangent of pi over 6, we can go back, sorry, I meant cotangent, slow down, cotangent. We'll go back and look at what tangent was. Tangent was square roots of 3 over 3, or we could even go back here to this relationship, and we know that cotangent is going to be root 3 over 2 over 1/2. So let's start from there. We know that cotangent is cosine over sine. We flip the bottom, multiply straight across. That cleans up very nicely to square roots of 3. So there are all 6 trig measures, all 6 trig ratios for an angle measure of 30 degrees or pi over 6. So let's go back to the plane. And now let's do the same thing that we did on yesterday's lesson. Let's do it for this triangle. This is a measure of 30 degrees. Pi over 6 is equivalent to 30 degrees. We said that we know that this is the x coordinate. That distance is x. For the 30-degree angle, that's the adjacent side. We know that this is our y measure. It's a value of y above the center of that circle. We know that our radius is 1. We are in the unit circle. And we know that this is the opposite side of our angle measure that we have here at the origin. So we said that we know that this measure is going to be equivalent to our cosine, and we said that cosine was the square roots of 3 over 2. We know that this measure is going to be equivalent to our sine, and we said we knew that measure was 1/2. So again, here is the cosine of pi over 6 and the sine of pi over 6. And if we know those 2 trig ratios, we can come up with the other 4 just based on the relationship that they have with sine and cosine. And now we're going to do the same thing with this pi over 6 angle measure that we did with pi over 4. If we know the coordinates to that point in the plane that correspond to the cosine and sine of pi over 6, and we're in quadrant 1, we can reflect that over the y-axis and find the sine and cosine measures for this point on the surface of that circle, where the angle measure is 5 pi over 6. This angle measure right here. And so based on what we know about being on the negative end of the x-axis and the positive end of the y-axis, we know the coordinates of this point are negative root 3 over 2, but still positive 1/2. So the cosine of 5 pi over 6 has to be negative root 3 over 2, and the sine of 5 pi over 6 has to be a positive 1/2. We'll again reflect it down into quadrant 3, and you can see very easily that everything that we did before, reflecting over the y-axis to get to 5 pi over 6, and there are our sine and cosine values, will reflect over the x-axis, and now this angle measure is 7 pi over 6. Here is the coordinates to the point in the plane on the surface of that circle. Here is the cosine of 7 pi over 6 and the sine of 7 pi over 6. We reflect this again over the y-axis, and it brings us to an angle measure of 11 pi over 6. Here are the cosine and sine for that angle measure. So we can do what we did with our pi over 4 on the last lesson, and we can do the same thing with all of those equivalent pi over 6 measures all the way around. There's 5 pi over 6, 7 pi over 6, and we come around here to 11 pi over 6. So we have all of those exact values for sine and cosine just based on what quadrant we're in and the sign, the positive or negative sign that's attached to the coordinates of that point in the plane on the surface of that circle with radius 1. Now we'll go back up here and we'll do the same thing with our pi over 3 angle measure. Let me try to get rid of this quickly. I'll try to watch for when the time is up on this video, but it may run out on me if I don't pay attention. Now we're going to talk about this angle measure, because now we have our 60-degree angle right here at the origin. So we drop the altitude, we're still in a 30, 60, 90, but now we're talking about what is a radian equivalent to 60 degrees, and that's pi over 3. So here is our y coordinate. It's still the opposite side to our angle measure. Here's going to be where we're going to get our x coordinate. It's still the adjacent side. So notice that this is the short side and this is the long side on our 30, 60, 90. So let's go back and let's find those measures when our hypotenuse is 1. Our short side is still 1/2. We are still in the same right triangle with our 30, 60, 90, so those side measures haven't changed. But now this is the opposite side and this is the adjacent side. So when I talk about the cosine of pi over 3, that is adjacent over hypotenuse. So now cosine is 1/2. When I talk about the sine of pi over 3, that's opposite over hypotenuse. So now the sine measure is root 3 over 2. And we could go ahead and find tangent and secant and cosecant. We won't worry about doing that now, but we could definitely do that. So the coordinates to this point in the plane, the first one is the cosine, so that's positive 1/2, and the second one is the sine, so that's root 3 over 2. There's the cosine of pi over 3. Here's the sine of pi over 3. And if we take this and reflect it, just like we did with our 30-degree angle in the plane, we take this one. We know that the coordinates of this point are 1/2 root 3 over 2. See how that switched those for the 30-degree angle measure? If we reflect this over the y-axis, we're now at an angle measure of 2 pi over 3. There's 2 pi over 3. But we know the coordinates of these points. It's the same x distance, but now we're on the negative end of the x-axis.